Today we are going to see Open System Interconnection or OSI model. First, let's see what is the need for a layer. Let us consider two friends who communicate through postmail. The process of sending a letter to a friend would be complex if there were no services available from the post office. Similarly, in order to establish a successful connection between computers or networks, 7-layer OSI model was introduced by ISO. The OSI model is a layered framework for the design of network systems that allows communication between all types of computer systems. An open system is a set of protocols that allows any two systems to communicate regardless of the underlying architecture. The OSI model has totally 7 separate but related layers, each of which defines a part of process of moving the information across a network. It was introduced in late 1970s. These are the 7 layers of OSI model. The 7th layer is application layer, then presentation layer, session layer, transport layer, network layer, data link layer, then at last physical layer. The layer 1 to 4, they relate to communication technology, and the layer 5 to 7, that is 5, 6, 7 session layer, presentation layer and application layer. It relates to the user application. OSI layer is divided into two layers, upper layer and the lower layer. Upper layer deals with application related issues and they are implemented only in a software. Application layer is closest to the end user, whereas the lower layer of the OSI model, it deals with data transport issues. The data link layer and the physical layer are implemented both in hardware and in software. Physical layer is the lowest layer of the OSI reference model. Those 7 layers have some specific functions, like application layer is used to allow access to network resources, presentation layer is used to translate, encrypt and compress the data, session layer is used to establish, manage and terminate the sessions. Transport layer is used to provide a reliable process-to-process message delivery and error recovery. Then the network layer is used to move the packets from source to destination. Data link layer is used to organize bits into frames, and physical layer is used to transmit those bits over a physical medium. The 7th layer is the application layer. This is the OSI layer that is closest to the user. It provides a network service to the user's application. It serves as a window through which the application processes can access network services. This would be the layer that the programmer uses to allow his application to access a network service like linking into a database. Now let's see the functions of application layer. Network Virtual Terminal is a software version of physical terminal. It allows a user to log on to a remote host. The major function of application layer is file transfer. File transfer is done through FTTP protocol. FTP protocol, that is file transfer protocol. Then web serving is done using HTTP protocol, hypertext transfer protocol, email through SMTP protocol, simple mail transfer protocol, and virtual terminal using the telnet. It also has other functions like mail services and directory services. Directory services, it provides a distributed database sources and access for global information about various objects and services. The next layer, that is 6th layer, is presentation layer. Presentation layer is mainly concerned with the syntax and semantics of information exchange between the two systems. So that's why the presentation layer is also known as syntax layer. Presentation layer ensures the information the application layer of one system sends out is readable by the application layer of another system. And it acts as a data translator for the network. This layer is a part of operating system. that converts the data from one presentation format into another format. The function of presentation layer, it is mainly responsible for translation, compression, and encryption. It deals with actual formatting of data. For example, data might be converted from FCD to ASCII format so that the receiving node can understand it. It is responsible for translation. The processes in two systems are usually exchanging the information in form of characters, strings, numbers, and so on. So the information should be changed to bit streams before transmitted so that the computer can able to understand. Another major function of the presentation layer is encryption. To carry a sensitive information, the system must be able to ensure some privacy. So that privacy part is taken care by the presentation layer. The encryption means the sender transforms the original information to another form and sends the resulting message over the network. While doing decryption, it reverses the original processor to transform the message back into its original form. And it also plays a major role in compression. Data compression will reduce the number of bits content in the information. Like we consider a 5 MB file, if it is compressed into a 2 MB file, it can reach the destination within a short period of time, which is an advantage. Next layer is session layer. Session layer is responsible for dialog control and synchronization. The name itself suggests that the session layer will establish, manage, terminate the sessions between two communicating hosts. Let us see the functions of session layer. It has dialog control and synchronization. Session layer allows a process to add some checkpoints or synchronization points to a stream of data. Like we will consider an example. If a system is sending a file of 2000 pages, it is advisable to insert these checkpoints or the synchronization points so that after every 100 pages, it ensures that each 100 page unit is received and acknowledged independently. If in case a crash happens during the transmission, that particular page can be resended because the acknowledgement won't be received. So that it is very helpful. Next is transport layer. This is the fourth layer. Transport layer is responsible for delivery of message from one process to another. It receives the data from upper layer, converts them into smaller units known as segments. So in this transport layer, the data has been converted into segments. It makes sure that the data arrives without any errors in a proper sequence and in a reliable condition. This process is termed as an end-to-end layer as it provides a point-to-point connection between the source and destination to deliver the data reliably. There are two protocols used in this layer. First one is Transmission Control Protocol TCP, another one is User Defined Protocol UDP. Transmission Control Protocol. It is a standard protocol that allows the system to communicate over the internet. It establishes and maintains a connection between the host. When a data is sent over a TCP connection, then the TCP protocol divides the data into smaller units known as segments. Each segment travels over the internet using multiple routes. They arrive at different orders at the destination. The transmission control protocol TCP will reorder the packets in a correct order at the receiving end. The next, another protocol is user-defined protocol. It is a transport layer protocol. It is an unreliable transport protocol, and as in this case, the receiver does not send any acknowledgement whether the packet is received or not, whereas in TCP, an acknowledgement will be sent. In UDP, acknowledgement is not sent whether the packet is received or not, and the sender does not wait for any acknowledgement. So only this protocol is known as unreliable protocol. Functions of transport layer are segmentation and reassembly. When a transport layer receives the message from the upper layer, it divides the message into multiple segments, and each segment is assigned with a sequence number that uniquely identifies each segment. Another major function of the transport layer is flow control. Consider like a system is capable of sending a data at 100 Mbps rate, but the phone can able to receive or send only at 10 Mbps rate. If the system is sending more than 10 Mbps rate, the phone cannot receive that data. So the phone sends an information to the system through the transport layers, saying that it is capable only at 10 Mbps rate, so that the system will send the data within the 10 Mbps rate. In this case, this transport layer controls the flow. Then service point addressing. Service point addressing is also called as port addressing. It is nothing but the transport layer adds a header that contains the address. Next major function of transport layer is connection control. Transport layer provides two services, that is connection oriented service and connectionless service. When we see connectionless service, it treats each segment as an individual packet and they travel in a different routes to reach the destination. Whereas when we see the connection oriented service, all the packets travel in a single route. The third layer is the network layer. The data in this layer is called as packets or datagrams. The network layer is responsible for the delivery of individual packets from the source host to the destination host. It determines the best path to move the data from source to destination based on some network conditions and priority of services and other factors. It manages the device addressing and tracks the location of devices on a network, and it is responsible for routing and forwarding of the packets. Routers are specified in this layer and it is used to provide a routing services with the internetwork. The protocol which is used to route the network traffic, they are known as network layer protocols. Examples of such protocols are IPv4 and IPv6, internal protocol version 4 and internal protocol version 6. Functions of network layer are internetworking. And internetworking is the main responsibility of the network layer. It provides a logical connection between different devices. Addressing. A network layer adds a source and destination address to the header of the frame. Addressing is used to identify the device on the internet. Then we saw in earlier also about routing. Routing is a major component of the network layer and it determines the best optimal path out of multiple paths available from the source to destination. Then the next function is packetizing. It refers to the process of encapsulating the data received from the upper layer of the network and decapsulating it at the destination, and this process is known as packetizing and it was achieved by the internet protocol. Now, like, the packetization makes easier to transfer the data packets and it helps to eliminate the single point of failure in the data communication. The second layer is the data link layer. Data link layer is responsible for moving the frames from one node to another. The data units on the data link layer is known as frames. And this layer is responsible for error-free transfer of data frames, and it provides a reliable and efficient communication between two or more devices. And it also defines the format of data on a network. The data link layer has two sublayers like logical link control layer and media access control layer MAC layer. The logical link control layer is responsible for transferring the packets to the network layer of the receiver that is receiving, and it identifies the address of network layer protocol from the header, and it also provides the flow control. Next is the media access control layer. This layer is a link between the logical link control layer and the network physical layer. It is used for transferring the packets over the networks. Now let's see the functions of data link layer: framing, physical addressing, flow control, and error control. Framing: the data link layer will translate the bitstream into packets known as frames, and it adds an header and trailer to the packet. Next is physical addressing. In this, the data link layer will add an header to the frame that contains the destination address. Next is flow control. It is the main functionality of the data link layer. It is a technique through which the constant data rate is maintained on both sides so that no data gets corrupted. The next is error control. Error control is achieved by adding the CRC value, that is cyclic redundancy check value, that is placed to the data link layer's trailer, which is added to the message frame before it gets sent into a next layer known as the physical layer, that is the first layer. And if any error seems to occur, then the receiver sends an acknowledgement for the retransmission of the corrected frame. Physical layer is the first layer. It is responsible for movements of individual bits from one node to the next node. The data units on this physical layer is called as bits, and it is the lowest layer of the OSI reference model. It establishes, maintains, and deactivates all the physical connection. It specifies the mechanical, electrical, procedural, and then network interface specifications also. These are some of the functions of physical layer like line configuration, data transmission, topology, signals. So the line configuration, it defines the way how two or more devices can connect physically. It is concerned with connection of devices to media like point to point or a multi-point connection. The next is data transmission. It says whether it is a simplex, off duplex, or full duplex mode of data transmission between the two devices on a network. The next function is topology. It defines the way how the network devices are arranged. And the next function is signals. It determines the type of signal used for transmitting the information. Data rate is the transmission rate. The number of bits sent each second is also defined in this physical layer. Next function is synchronization of bits. The sender and the receiver not only use the same bit rate, but also it must be synchronized at the bit level. Like in other words, we can say that the sender and the receiver clocks must be synchronized. Next function is representation of bits. The physical layer data consists of stream of bits with no interpretation. This is the quick summary of the layers which we saw before. The seventh layer, application layer, is used to allow the access to internet resources. Then the sixth layer, presentation layer, is used to translate, encrypt, and compress the data, and it sends the data to the session layer. The session layer, in turn, it will establish, manage, and terminate the sessions with the transport layer. The transport layer will provide a reliable process-to-process message delivery. Then the network layer, the data units in this network layer is known as the packets, which we saw earlier. To move the packets from source to destination, this network layer is used, and it provides the internetworking, which is the major function of the network layer. Next, it sends the data to the, that is the packets to the data link layer. It will organize the bits into frames. The data units in this data link layer is called as frames. Then the data units in the physical layer is known as bits. It will transmit the bits over the physical medium. Thank you for watching.